Susie, what are we accomplishing today? Read the I can statements for me.
Solve a system of equations algebraically to find an exact solution.
By what?
Substitution and elimination.
And we did substitution and elimination the last 2 days, yes?
Yes.
Pierre, what's the other objective? What's the other I can we're going to do today? What? What are we doing? Context. What's that mean if we're going to be dealing with real world scenarios? Real life stuff. What's some real life stuff that we could be dealing with? Some food. Talked about a little bit of it yesterday, right? What else? Some money. Anything else?
Houses.
Some houses. We're going to take all of the equations that we've been doing, put some word problems together where you might actually use it in real life. Yes, no, maybe? How do we do on these? What do I need to do to number 1? Paul, what'd you say? Get my... Where?
Over there.
How do I move this to the other side? Add it, change the sign, right? So this is actually going to be what?
6x
6x plus y equals 8. Is that in standard form now? Yes. All we had to do was move that 6x, right? What about number 2? What's not where it belongs? The 8, the C, right? So the 8 has to move. When that moves to the other side, what happens to it? Alright, what do we say needs to move? How? So if I subtract the 8, what happens? Do I leave it 3y?
No.
What has to go first? So I get negative 2x. What else? Plus 3y equals negative 8. Yes? If we have them both in standard form, what method do I use to solve systems? Elimination. Both of them need to be in standard form for what? Elimination. What about 3 and 4? What am I trying to get them to? How do I do this one? Move the what? Move the x? Divide by y. So what's that get us? I've got 6x minus 2y equals 12. What happens? Move the 6x. So I've got negative 2y. What goes first? 12 or negative 6? So I've got negative 6x plus 12. Divide by negative 2. And what do I get, guys? Negative divided by negative? Positive 3x.
Minus 6.
Minus 6. Good job. How are we doing on these? I'm seeing some writing. Did we miss some signs?
I just put the 6
So did you do negative 6 plus 3x? That's fine. Did you guys hear what she said? She said she wrote this. Are those the same? They're the same exact thing, are they not?
Yes.
What happened to them? We just switched. Does that change which one the slope is? Which one's the slope? Not the x, just the 3. Yes? What about number 4?
Divide by 8.
The y is almost already by itself, right?
Yes.
So I've got 8y equals 24 minus 8x. And I take a set to do what? Just divide by 8. So what do I get? 3 minus 1x. What's another way I could write it? Y equals what? Negative x plus 3. If they're both in slope-intercept form, what method do we use?
Substitution.
All right, homework. And yay, we all did our homework today. How often does that happen?
Every day.
Anybody want to do number 4? You want to come do it? Does anybody want to do 10? Or is that the one most of us need help on?
I would do it, but I don't think it's ready for us.
That's okay. You want to try? You got 10? I'm going to put it over here. Alright, and what method should we have used last night for homework? Elimination. Looking at those two, the last 2 days, what do we like better?
I like elimination.
Y'all like elimination better? Doesn't matter? Are we always going to be able to just use one or just use the other? It depends on how they give us the equations, right? Let's see how they're doing. Let's see. You guys need to be checking your paper, making sure yours looks like theirs. Alright. In order to eliminate, what has to happen?
You got different signs.
Different signs, but same number, right? I've got 2 5s. One's a positive, one's a negative. So did I need to multiply with this? So what variable were we eliminating first? The x. So Jordan just did that and added down, right? So we got 5y equals negative 15. So y got us negative 3. Yes?
Yes.
Are we done here? No. What do you do next? Plug it back in. Doesn't matter which equation. So he chose the second one. Negative 5x minus 27 equals 8. Added the 27 and got x to be negative 7. So the answer is what? Pay attention to that. Don't try to put negative 3, negative 7. What always goes first? The x. Where was the confusion? Because there was a lot of you that said you weren't sure about that one. It doesn't matter which one you plug it in. Guys, once you solve for this first variable, it doesn't matter which equation you plug it in. So Jordan did the second one, right? Say I choose the first one. So I've got 5x minus 4 times negative 3 equals negative 23. What's this going to get me if I chose the first one? 5x plus 12 equals negative 23. Subtract the 12. We got 5x equals, when there are 2 negatives when we're adding, what do? Add them and make it, so 5x equals negative 35. Look. Is that pretty much the same thing? When I divide by 5, what am I still going to get? Negative 7. So it doesn't matter which equation you choose. No. Don't choose the easiest one. And I'm thinking Jordan chose this one because it was more positives than negatives. But did it matter which one we choose? We okay? Number 4. I've got my 2 original equations, right? Do I have what I need? With what variable? 4 and negative 4. Both same numbers, different. So we added. Here's where we added, right? So what is this really saying? 9 minus 7. What's 9 minus 7? Positive 2. Is that okay that we made a mistake? Yes. But pay attention to the signs, right? So is that going to change everything? This is going to become a positive 2. So we'll divide by positive 2, right? So what does that get me? Negative 6 divided by positive 2 changes this to a negative 3. You ready? So that's going to change over here just a little bit, right? So we're still going to have 4x plus 9, but this time it's going to be a negative 3 equals negative 19. We've got 4x minus 27 equals negative 19.
And 27.
Now we're adding 27. So we got 4x. Do I really want to look at this as negative 19 plus 27? What's the easier way to look at that? 27 minus 19. What's 27 minus 19? 8. Divide by 4. X equals 2. How do we do on those two on your own? We did okay? Elimination is good? So we ready to do some work? Everybody has paper? Everybody has a highlighter? Okay. Guys, can we get different colors? And we kind of did a little bit yesterday, right? We talked about it, introduced it. Is everybody on number 1? Who wants to read it? Sharon, you already read it. Kiara already read it. Should I go ahead and read number 1?
You are selling tickets for a high school basketball game. Student tickets cost $3 and general admission tickets cost $5. You sell 350 tickets and collect $1,450. How many of each type of ticket did you sell?
Where do we start?
Highlight.
Before we highlight, we read the problem, right? Very first thing, read the problem, understand what it's asking about. What are the two different things we're dealing with? We're dealing with money and we're dealing with tickets. Does everybody see that?
Yes.
But not only are we dealing with money and tickets, what else? Is there any other two things that are different? What do you say, Paul? The student tickets and the general admission tickets. So, yes, we need both of them. And I'm going to abbreviate. We've got general admission and we have student. Which one are we really dealing with? Where do we go now? After we read the problem, after we find out what we're talking about, where do we go next in that problem? What's the most important sentence? The question, where's that found? At the end. That's going to tell you what to do everything with, right? What are we looking for? How many of each type of ticket did you sell? So are we looking at the money and the tickets? It's asking for each type of ticket. What are my two types of tickets? General admission and students. So you guys see how on the side there's kind of like a graphic organizer?
Yeah.
Underneath the first part it says to define the variables, right? What variables should we use? X and Y. What do you want to make X? What do you want to make Y?
Money.
Well, we're not dealing with the money and the tickets. We need this in a second, but we're dealing with the general admission and the student because that's what the question's asking us for, right? What do you want to make what? General admission X, students Y. Now we got to get our equations, right? How many equations? 2. Cara said money and tickets. Those are my two different things we're dealing with, right? So now let's go through the problem. You're selling tickets for a high school basketball game. Student tickets cost what?
$3.
So the students are $3. What else does it say? General admission is $5. What else is important? You sell what? 350 tickets and you collect $1,450. Knowing that, how are we going to set up two equations? Are we going to go standard form, slope-intercept form? Do we know yet? We got to look at what it's asking us. What's it start out saying?
Students.
Students are what? So what am I going to do?
You gotta go to slope intercept.
3y. Yes? Because it's $3 for the...
Students.
So I'm going to write 3y. Why did the 3 go with the y? It's the students. You with me so far? What's this word mean? Add. So I'm going to add what? 5x. What's it going to equal? I think it says 350. Georgia says 1,450. Which one is it? Ours says 1,450. What are the two things we're dealing with? Money and tickets. This 3 had a what with it? It's $3. Let's talk about money, right? The 5 had a what with it? So we're dealing with money, money. So what's it got to be equal to? Money. What's the other money sign? What's the other dollar sign up here? 1450. Guys, always, money goes with money. Money always goes with money. And they'll try to confuse you like that. That's why I left this up here. So the first equation dealt with all of my money. What's my next equation going to deal with? So I already used 3. I already used 5. I already used 1450. What's the only thing left? 350. Can I create an equation with just one number? But I need another equation, right? So what am I going to do?
You're gonna solve the first one, plug in.
You said I'm going to solve and plug in. Not quite. What did you say? You say use the 3 and 5. Can I use the $3 and the $5 again? No. Guys, how many tickets are being sold? 350. What are those tickets made up of? Yeah, the actual ticket itself is paper. But deal with what I've got up here. You go to a basketball game, right? And this is what it's talking about. You guys are going to pay $3, right? Because you're a student. How much am I going to pay? 5. How many tickets are being sold? So what are those tickets made up of? 350 is the total, so we know it's going to be equal to the 350. We know we sold 350 tickets. That's my total. What types of tickets did we sell? Basketball, but give me more specific. What types? Students and... Do we know how many of each we sold? We know, though, we sold to students and to general admission, right? What am I going to put up there? We just said, what are my 350 tickets made up of? General admission and... So what am I going to put?
X and Y.
X and Y. What's going to go first? Well, X generally, but what do we put first up here?
Y.
So guess what? What's this going to be? Y and X. Because there's 2, 4, 6, 8. There's 10 of us in this room, right? So if we just went and said, okay, we sold 10 tickets. Do they know it's 9 students and 1 general admission? But they know they sold how many? 10. So with this, we know we sold 350, right? And what were the 2 types of tickets sold? Students and general admission. We okay here? Now we gotta solve it. How are we gonna solve this? What way? Elimination or substitution? Which way do you think is going to be easier?
Elimination.
Who says substitution? 2 of you? Who says elimination? 2 of you and about 3 of you didn't agree. For me personally, I would do substitution. Why? These are already by itself, right? So if I'm doing substitution, what equation do I change? The first one or the second one? The second's going to be easier because, Paul, the second, the x and the y are kind of already by itself, right? If I tried to change this, I'd end up with a fraction. If we don't have calculators, do we want to make it messy? We want to make it as easy as we can, right? What variables can I solve for? Does it matter? Because they're both by themselves. Pick one. Y? You would say x. Y was the first thing I heard, so what am I moving? Move to x. Susie, why are you getting backwards today? So what does this end up with? Negative x plus 350, right? Underneath solve, because now we're trying to solve it, right? So we defined the variables, didn't we? We defined the variables here, right? The next part says your system of equations. What's my systems of equations? These two right here, right? Now we're starting to solve by what in this case? How are we solving this? What method did we choose? Substitution. We're not there yet. Did we solve it yet? So what am I doing now, guys? Taking the y out of the first. So what am I writing, Susan? 3.
Negative x plus 3 plus 5x equals 1450.
What did we put for systems of equations? What did we put in that part of the graph? The two what? Not the two problems. The two equations. So what do I get? What am I doing here? Distributing, right? Negative 3x. What do I do if I really don't know what 350 times 3 is? Go over to the side, and guys, we got to get used to this. You got your 350 times 3. That's 0, right? What am I getting now? 5, carry the 1. 9, 10. So what's it equal to? 1050. Y'all have been given a calculator so long. We good to hear? Now what? Combine my terms. What's going together? Negative 3, positive 5. What does it give me? Positive 2x. The bigger number's positive. Atika, look at this. This is really saying 5 minus 3, right? So 2x what? Plus 1050 equals 1450. Now what? Subtract 1050. What do I get? 2x equals 400, right? Plus 5, 0, 0, 4, 400, right? Now what? Divide by 2. So x equals 200. So tell me what that means. 200 what? What type of tickets? Student tickets, right? You sure? You sure? What do we say our X was? General admission. So it's 200 what? General admission. If it's a multiple choice question, will they have 200 up there? Yep. Are we finished? Pick the easier equation, which was x plus y equals 350. What am I doing? Plug in what? So what's this? What am I writing? 200 plus y equals 350. And what's y equal to? 150. 150 what? Students. So one last thing you got to fill out. State your solutions. What are you really going to write in there? 200 general admission and 150 students. I want to skip number 2 and jump to number 3. Drew, you got it? Go ahead.
You are in charge of decorating the gym for the homecoming dance. You purchased 6 bags of balloons and 5 bags of large sparkling hanging stars, all for $19.20. You soon realize that this is not enough to decorate the entire gym. On your second trip to the store, you bought 8 bags of balloons and 2 bags of large sparkling hanging stars, all for $15.80. What was the price for each item?
Guys, they put a whole lot of extra words in there that they didn't even need to do. Why? To throw you off, to make you shut down, to try to confuse you. Did we need to know that they were large, sparkling, hanging stars? No. We didn't need all that, did we? So don't let the extra words throw you off. What are the 2 different things that we're talking about?
Bags.
Balloons and
Stars.
balloons and stars. So go ahead and define your variables. So what are the 2 things that we're talking about?
Balloons and stars.
Balloons.
And
Large
sparkling
hanging
hanging stars.
You can write that if you want to, I'm not. Balloons and what? Stars. Guys, make it as simple as you can. Don't complicate yourself. So what are you saying the balloons are going to be? Balloons are X. Stars are Y. We just defined our 2 variables, yes? Do you always have to use X and Y?
No, use A.
We could have used A and B, C and D. In this case, I could have used B and X.
S and B.
All right, what am I highlighting? We've got 5 what? Bags of what? We got 5 bags of stars, ladies. What else? We got 1920. Did you miss something up there though? You purchased what? 6 what?
Balloons.
6 balloons. So we've got 6 bags of balloons, 5 bags of stars, and it cost us how much? $19.20. Yes? Linda, what else am I highlighting? 8 bags of balloons. 2 bags of stars for $15.80. This one's going to be different than the last one. Because the last one we put all the money in one equation, right? And then we put the tickets in another equation. Well, if I put all of the balloons in one and the stars in another, am I going to have 2 different variables? No. This one, pretty much the way it's written, is how you're going to set up your equation. Because you went to the store and bought some stuff, right? So what are my 2 equations going to be? 6x plus 5y equals 1920. The way we read it is pretty much the way we wrote it, but pay attention. Do you know what they might try to do? They might try to go ahead and say 6 balloons and 5 stars, which is the way we wrote it for the first equation. But what might they try to do on the second equation? They might try to tell you 8 bags of stars and 2 balloons. So what did they do? Or what might they do? Switch the what? The X and the Y. Don't let that confuse you. We know everywhere we see balloons, we're putting a X. Everywhere we see stars, we're putting a Y. So what's my next equation? 8x plus 2y equals 1580. So we defined our variables, right? Did we state our systems of equations? We did. We just did, right? So what's my next step? How are we going to solve this one? Jordan says elimination. I heard substitution. Is there really an easy way for this one? Does anything just stick out to you? Not necessarily. So probably what are we going to do? Eliminate. elimination, and we're going to have to what? Multiply. We okay to hear? Did I lose anybody? You sure? So what do I have to do? We decided we're going to use what method? Substitution or elimination? Elimination. What variable you want to eliminate? Which one will be easier? I keep hearing why. How can I get the 6 and the 8 to be alike? But they have to be the same. Are 6 and 8 the same? No, so we're going to have to multiply, right?
Yeah.
You think it'll be easier to multiply the 6 and the 8?
Yes.
Or the 5 and the 2?
6 and 8.
In this case, when you get this on your own, you pick whichever one. Is everybody going to do it the same way? No. But pick the easiest way. I think, which one?
6 and 8.
I'm probably going to get rid of the y, the 5 and the 2. Why? Because what am I going to multiply 5 by? 2. What am I going to multiply 2 by? 5. That's easier, right? The 6 and the 8. If I multiply 6 times 8, what type of number does that give me? What's 6 times 8?
54.
Not 54. What's 6 times 8? 48. That's kind of a bigger number, right? Do we want to get 48?
No.
Well, what's 5 times 2? 10. That's a whole lot easier to deal with than 48, isn't it? So what am I going to multiply the top by?
2.
2. Paul told me 2. What's the bottom going to be?
5.
5. What's wrong though?
No, negative 5.
Which one's going to be negative?
Ain't neither one.
Does it matter?
Yes.
So the 2 or the 5?
The 5.
5.
The 5. Does it really matter?
Yeah.
Why did we choose 2? Why did we choose 5? Because that'll make the y's into what? What number will that make the y's into? 10. So what's my new equation at the top going to be? 12x plus 10y. Uh-oh, here's some math. 19 times 0, 4, 8. So what is it? 3840. What's my next equation going to be? Negative 40 minus 10y. We have to come over to the side again, right? Zero. 40. So 40, so what do I write?
0.
Carry the 29.
32.
So what's it get me? I forgot something. Why is it negative? This one's going to be a little bit more, guys. But this is the type that you're really going to see on the EOC. They're not going to make it easy for you. They're going to make you have to do some math. Those cancel out, right?
Negative 38.
Negative 38? What's 40 minus 12? What am I doing?
1.
So what do I get?
12.
8. 3 minus 1 is? But what type of 28? Negative 28x equals, well, 79 minus 38, 40. Y'all do some math today. X is, anybody do it?
Nope.
I X is what?
It's probably like 2.
X is
2.5.
1.45.
$1.45.
Yeah.
Now what do we have to solve for? Stars. So what am I doing? Plug in which one? Which one do you want to use?
Top. No, bottom.
The bottom.
Doesn't matter. The bottom?
Top.
So 8 times what? Plus 2y equals 1580. You guys can do 8 times 145. Go ahead and do it. Jordan got 1160? It is 1160. So now what? Y'all starting to get silly on me. Come on. What's 8 minus 60 is, what's 15 minus 11? 4. Now what? Divide by 2. And y is 210. So, what's your actual solution? What are you writing? The balloons cost how much? $1.45. These stars cost how much? $2.10. Do you guys like using the graphic organizer? Does that help you?
Yeah.
Yes or no? Who wants one of these to help with what we're going to do next? You don't have to. Some of you, I think it's better to keep you organized. Some of you don't like the chart. Paul, yes? Okay. So here's what I want to do now. We just went over these 2 problems. One of them was solving by substitution. The other was solving by elimination. There's a different type of problem in each one of the colored sheets of paper. Okay, there's a number on it. So, the colors mean something. What's the green mean you're going to solve by? The green word problems are going to be solved using, and the yellow are going to be solved using elimination. So, stay with your partner. Go to a word problem. There's different ones, so yes, you can write on it and mark on it. Okay? So, 1, 2, 3, 4, 5. The 3 y'all need to decide if you're working by yourself or working with a partner. By yourself, Paul? By yourself? Okay. So, there's 6 problems. Guess what? Go get to a set of desks. You'll see the number and start working on that. And yes, there's enough of these that you can write on. You can write on them when you get here. It's the word problems that we've been dealing with, the same similar type of what we just did these 2 practices on. I'm going to put some calculators at select ones. Paul and Durante are... If y'all are going to be at the same station, you're going to work together. If you're going to work by yourselves, one of you need to go to this other station. Y'all need to make that decision. I'm going to put some calculators at select stations. You can only use the calculators there. Can't use calculators at every one of them. Okay? Should probably take you 5 minutes per problem. You can write on the color sheets of paper, yes.
So we can write chicken.
Everybody else is already on there. Notice what's together. Chicken is what?
What do you mean?
Oh yeah, negative for the first one. Yeah, I was talking about 350
Plus
times.
to be your 5 meals, right? So you've got your night stay, you've got your meals. Those are your 2 different variables, right? Well now, which one of these are we looking at? Is this going to look similar to the first example that we did or the second example that we did? It's going to be closer to the second one. So as you're reading, what's it saying? 2 nights. But you just told me nights is going to be what? So you've got your 2 eggs with 3 meals. What do you think it's going to be? Plus 3y equals what? Yes. Guys, most of us, I know, are not finished on the first problem. We at least have it down so you can finish it later. You can finish it for homework. I need you to go to another station, but if you started with yellow, make sure you go to a green. If you started with green, make sure you go to a yellow. Yeah, Susie, calculator stays back there. Susie. Half of them you get a calculator, half of them you don't. So you guys know with green, we're doing what this month? Substitution. So is it going to look like the first example we did or the second example we did? The first one. Y'all know green is substitution, right? But then, this very first thing that you said, it says what? There are what?
6 people.
So that was like the first problem that we did, where we dealt with money and money all in the first equation, right? And then the second equation, we dealt with the different people and the tickets, right? So in this, you got a money, 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 all goes together. All of the money goes together. $6 had a dollar sign, right? 4 had a dollar sign. So what? Is it going to equal 21? It should really equal what? 104. 104. All of the money goes together. All right. Ladies and gentlemen, do we at least have all of the equations set up at the second station? Okay. We are running out of time. We're not going to have time to go on to another one. Does that mean lose these worksheets?
No.
No. We'll pick up and finish this tomorrow so we can at least get to 1 or 2 more stations. Okay? Leave the stations where they are. Leave the calculators where they are. What I need you to do tonight. Also, go back to your desk. When you get back to your desk, I passed back some papers that have been graded.
Is homework to go home?
Yes. Okay, does everybody have a homework sheet? Right here. Paul, do you have one? I just set them on your desk. Looks like this. Guys, stop looking at paper so you can get directions. Because the bell's going to ring in just a minute. For all of these, define your variable. Get your equation set up. So are you solving anything tonight? No. Define your variable and get your equation set up for all 6. Okay? So, coming back to this. Can we solve a system of equations algebraically? To find an exact solution using substitution?
Yes.
Yes. Why? How do we need substitution? Solving one equation, so getting one equation in what form? One's in standard, the other needs to be in slope intercept and plug in, right? Can we solve by elimination? What do I do for elimination?
Change the sign.
They both have to be in what first? Standard form?
And you got to have the same slope.
Same number?
Different sign.
Okay, can we interpret the variable and solutions in context of a real world scenario? Did we do that with the word problems?
Yes.
So when you got there, you didn't just get an answer of 4, did you? You said it was 4 steaks, or 4 breadsticks, or $4, right? Depending on which one it was. So, some of you have 2 things for homework. What's the first thing? Hold on. Finish this. What do you need to do? Define the variable, set up the equations, and the rest of y'all need to give me my progress reports. Have a good day. Bye.